My hope, and I failed at this dramatically last year, is to have some breaks and to have the end of the session be available for questions. Let's take a break. So science2010.jwedge.com will get you to my science page. When I get to it, obviously it's going to be not a big change, but there's a page with announcements, and I would ask you to periodically check those. Most of you who know me know that I have rheumatoid arthritis and pain. And so sometimes it's unlikely, but there's the possibility that I might have to cancel a class if things are too much. Very hard not to do that because I put a lot into these classes. I can't remember if there are W's in front of science, but I don't think so. For this second part, I want to talk about definitions. By the way, this is just water. All right. Most laymen who do not have science training, when they hear someone use the word theory, it's used in a colloquial sense, as I would call it. It's used in a sense as a guess. Well, that's your theory. However, in science, it's very different. There's a word called a hypothesis, hypo meaning under or beneath, or so it's not quite a thesis. It's a tadpole. It's not a frog. So for scientists, their guess will be phrased as a hypothesis. My hypothesis is that when you look at a glass of water and there's a pencil in it and the pencil doesn't line up, my hypothesis is that there's a change in density and the light bends as it goes through. And you would say, nice sounding hypothesis, prove it. A theory is usually more than one hypothesis that have been gathered together under one umbrella because they're all pointing in the same direction. So for instance, Newton's theory of gravity, which we call the law of gravity, implying that it will never change, and we all know that that's no longer true in high gravity and high speed situations. But a theory is something that has been repeatedly tested over and over, and the scientific method has several safeguards that we'll get to. Science itself is the study of the natural world using observations and experimentation, and the experimentation involves using natural forces, such as chemistry and physics and things that we already think we understand. The scientific method is on the back of your page. It's kind of long and drawn out and boring, but the basic idea is that, in my mind, most scientists are curious people. So if they see something that interests them and they don't quite understand that part of it, they will come up with an idea that might answer it, or they'll go to another person and say, listen, Joe, I can't quite wrap my hand around this. Why do you think that happens? Or how do you think that happens? Science is a very good how answering system. It is not a why. And as soon as somebody tells you this happens, gives you a why answer, you know that they've either strayed off scientific principles or they're using metaphorical language. And unfortunately, scientists publishing for lay people almost always use metaphors, and sometimes those metaphors don't hold up as well as they should. One of the things that I want you to notice is VIII. If you have a lot of tests which were designed to show that your hypothesis was wrong, that is to what's called falsify it, and every time you try and prove it wrong, it turns out that the answer is the other way, meaning that it was right. And that includes a process called proof by reductio absurdum. Well, one way of testing a hypothesis is to try and prove it wrong. And if you try and prove it wrong, and every time you do that, your experiment fails, what you've done is you've proven it to be correct within that experiment. All scientific information is conditional and temporary. You may remember a while back, when I was still practicing medicine, that we thought every woman should be on estrogen after they went through menopause, because at that time we thought that it protected the heart. And so I had a lot of women who were kind of, I'm not having hot flashes or things. It's really not that bad. Do I have to take this stuff? Well, it's supposed to protect your heart. They then came out with the longitudinal study of 20,000 nurses, showed no. So a whole lot of Premarin prescriptions got stopped because it actually increased the risk for breast cancer. One of the things that I wanted to talk about today without little stuff to write or show, and I'm going to try and have a different computer so that I can display things like images or YouTubes for you while we're doing all this other jazz. But first, close your eyes, close your mouth, stick your fingers in your ears.
Hearing aids make a difference.
Now think about that. What if instead of doing that, somebody did surgery on you and they cut your optical nerves, they cut your auditory nerves, and they very carefully cut the nerves from your senses touch, leaving all the things that regulated your heart and just digestion and breathing alone. There's a syndrome called the locked-in syndrome, where a person can be quite alive and aware, but they've had cerebral damage either by trauma or low oxygen that's caused this kind of an effect. And it's called locked-in syndrome. And sometimes these people can communicate by moving their eyes, and that's the only control they have over their body. And the thing that's a bit scary about it is that if you poke them, they can't react to tell you that they know you poked. But some of them can sense but not respond. Some can't sense. So it's very difficult if you're not careful for them to develop bed sores, because we're laying in bed and we always get a little uncomfortable. We'll just kind of, shift position. That tiny shift of position allows blood to flow into the areas that it used to be blocked. But if you don't have this kind of input, you just lie there like a lump. And pressure on the skin decreases blood flow. That area dies, basically, and you end up with bed sores, which are unpleasant. But the point that I was trying to make is that when you close your eyes and your mouth and your ears, how could you get information about the universe, the world? What's left? Nose. I was going to tell you to pinch your nose, but holding your breath. Let's pretend that you pinched your nose at the same time. Well, your mouth is closed. And let's pretend there's no air moving in and out. So nose, mouth, ears, eyes, all closed. The only thing you've got left really is touch.
Yeah.
You also have something called proprioception, which is a system where your body says to itself, I know, even though it's out of sight, I know which position my arm is in, and I can adjust the muscles according to that knowledge. So we get information about the natural world through natural processes that come into our senses. So everybody, does that make sense?
Yeah.
I can't begin to touch on things like dreams because I have no idea what the physical manifestation of them is. That's still a big area. Or hallucinations, for instance. There have been some interesting things where someone's put on a VR helmet, and instead of having the camera right where your eyes would be so that you're seeing on the screen the real world as it moves by, they take the camera and they move it 4 feet behind. And the person has what they will describe as an out-of-body experience, because they see themselves from behind and from outside, and they get this sense of dissociation that they have left their body, which I think is fascinating. Scary a little bit. We also know from a lot of studies, those of you who came to my How the Brain and Mind Work or Don't class, a lot of those books talk about the fact that our brains have modules. You have a sort of a visual module, auditory module, and so on, and they don't always interact perfectly. So we end up with a lot of strange things, including illusions, which is what that spinning top was about, and some other things. But I have a wonderful set of books and images about illusions, and that's something we could touch on if you're interested in. Lastly, in the quiz, I asked about dimensions of space. Now I want to ask you, what is time? I hear murmurs. Is there a scientist in the audience who could give us a definition of time? Okay, I think you've all actually hit it on the head. No one has a clue what time is. Honestly, time is something that we experience. That's about the only thing I can say. Time is something that we experience which allows us to have an awareness of change, movement, chemical change, but it is really tough to wrap your head around when you start talking about relativity and space-time instead of just time and space, but it's kind of fun, and we'll get back to that in more detail.